Hello, Algebra 2. Spring Final, review for Spring Final. All right, let's just start right away. Identify the asymptotes, domain, and range of this function. This was Chapter 4, the kind with branches, where there's a branch that does that and another one does that. So this is in graphing form. It tells me that it is, instead of the parent, that would be the parent one. Minus 2 means it's gone down 2. And x minus 4 on the bottom of the fraction means it's gone to the right 4. So I'm going to give that a little sketch. 1, 2, 3, 4 to the right. There is our vertical asymptote at x equals 4. And what was it? 2 down. So there is our horizontal asymptote, y equals -2. This top number of the fraction is positive, so that means the branches are going to be in the top right and the bottom left quadrants. All right, so asymptotes. The vertical asymptote is x equals 4. The horizontal asymptote is y equals -2. The domain, we're going forever to the right. Sorry, that's the left. But then it's stopping here at our asymptote, which is at 4. And then it jumps over the asymptote, and then it goes forever to the right. So we're going from -infinity to 4, not including it, and then in union with from 4 to +infinity. So that's interval notation. You can also write it in set builder at, inside of these x, such that x is all real numbers except for 4. So I put x is not equal to 4. And then the range is from negative, you always go bottom to top for the range. -infinity to the asymptote, which is at -2, in union with -2 to +infinity. And if I wrote that in set builder notation, y such that y is all real numbers except y not equal to -2. Number 2, write an equivalent form of f of x equals 3x plus 2 over x minus 2. Write it in graphing form. So when it looks like this, we need to change that to graphing form. We do that by division. 3x plus 2 is being divided by x minus 2. So we do specifically long division. 3x plus 2. All right, so x goes into 3x 3 times. And now I multiply. 3 times x is 3x. 3 times -2 is -6. And then we have to subtract both of them. And if I subtract a negative, that's plus. So I always had called that draw the line, switch the signs. 3x minus 3x is 0. 2 plus 6 is 8. And that is our remainder. There's nothing left over here to bring down. So I write our remainder as plus 8 over x minus 2. And then to switch that around, so it's in graphing form, I just put the fraction first. 8 over x minus 2 plus 3. And so there it is in graphing form. describe the end behavior of the function. So this is in the same format, so I'm going to do the same thing and write it in graphing form so I know where the asymptotes are. Oops. X plus 2 goes out here. So x goes into 4x 4 times. 4 times x is 4x. 4 times 2 is 8. Draw the line, switch the signs. Those add to 0. 1 minus 8 is negative 7. So we have plus negative 7 over x plus 2. So I'm going to write this normal, put the fraction first, negative 7 over x plus 2, and then we have a plus 4. What are we doing? Saying the end behavior. So I'm going to make a little sketch of this so that I can make sense of it. So it's 1, 2, 3, 4 up. There is our horizontal asymptote, and then to the left 2 for our vertical asymptote. And it's a negative 7, negative, so that means the branches are in the upper left and bottom right quadrants. I'm just going to make my asymptotes a different color so my brain can do this, not mix it up with the axes. All right, so for end behavior, you have two parts. As x approaches positive infinity, that means on the right. As x approaches negative infinity, that means go along the x-axis on the left. And then you have the second half of that statement. F of x approaches what? Comma, f of x approaches what? So f of x is the y, the up and the down. So as x approaches positive infinity, as you go to the right, what is the graph approaching? So those two are right left, and these are up down. So your brain is thinking along the y-axis. So as we go to the right, this graph, it's trying to go up, but you can never go past the asymptote. The asymptote is at 4, so it is approaching 4. As x approaches negative infinity, the left side of the graph, it's trying to go down. It is going down, but it's never going to go over that asymptote of 4. And that's our end behavior. Left side, right side. Is it going up or down? Translate the graph of 1 over x, 3 units down, 2 units left. Write the new equation. All right, so we're going to have 1 over 3 units down means it's a minus 3 on the outside of the fraction. 2 units left would be left is x plus 2. Inside there is always does the opposite. All right, and is that the same equation as the one? Yep, that's the same equation as number 3, so we already put it in graphing form. Negative 7 f of x equals negative 7 over x plus 2 plus 4. All right, so we've got our horizontal asymptote and our vertical asymptote, and let's do it the good old-fashioned tried and true method. You're going to plug in x values. So what x values do I plug in? Well, I know there's a branch right here just to the left of negative 2, an x value of negative 2. And then we have another branch on the right. So let's do the left one first. I'm going to plug numbers in to the left of negative 2. So like negative 3, negative 4, etc. So if I plug in negative 3 where the x is, that would say negative 7 over negative 1, which is 7, and then plus 4 is 11. So right about right there. Maybe that's a little high. That's okay. Plug in negative 4. Negative 4 plus 2 is negative 2. So we have negative 7 over, let me get my screens all up and everything. Negative 7. Oh, okay. I think I may have the wrong. Nope, this is a part of it. Negative 7 over negative 2. Sorry, you guys. Negative 7 over negative 2 is positive 3.5 plus 4 is 7.5. Plug in, let's graph that. To the left 4, up, where's negative 4? Up 7.5. And now we're going to plug in negative 5. I just want to get do enough points so that you're getting within 1 unit of the asymptote. So wherever that happens, you never know. You just got to keep plotting points. Negative 5 over 2, or sorry, negative 5 plus 2, and plug it in here, is negative 3. So negative 7 over negative 3 is about 2.3333 plus 4 is 6.3. So to the left 5, up 6.3. So we're slow curving it over there. I'm going to jump to negative 7. So negative 7 over negative 5 is 1.4 plus 4 is 5.4. Negative 7, 5.4, and I'm going to jump and do maybe negative 9. I just want to get within 1 unit of that asymptote. Negative 9 plus 2 is negative 7. Negative 7 over negative 7 is 1. 1 plus 4 is 5. Negative 9, positive 5. So there's that branch. And now we want to plug in x values to the right of negative 2. So we'll start with negative 1. I'm going to rewrite my equation right here so that I can look at it. X plus 2 plus 4. So negative 1 plus 2 is 1. Negative 7. Negative 1 plus 2 is 1. Negative 7 over 1 is negative 7 plus 4. Negative 7 plus 4 is negative 3. Negative 1, negative 3. And I'm going to plug in a 0. 7 over 2 is negative 3.5 plus 4 is 0.5 over 0 up 0.5. And I think I'll hop over to 2. 2 plus 2 is 4. Negative, this calculator is so, negative 7. Negative 7, 2 plus 2 is 4, so negative 7 divided by 4 is negative 1.75 plus 4 is 2.25, so 2.3, because it's hard, we can't, you got to keep it to tenths, the tenths place. Over 2 up 2.3, and maybe 4. Negative 7 over 6 plus 4, so negative 7 divided by 6. equals, and then plus 4 equals 2.8. What did I do? 4 over 4 up 2.8. I'm going to scoot over and do 6. Negative 7/8. 6 plus 2 is 8, plus 4. 7 negative divided by 8 equals plus 4 equals 3.1. What did I plug in? I plugged in 6 over 6 up 1, 2, 3.1. So now I'm within 1 unit of the asymptote. That was really bad. There we go. And it says graph, make sure to identify any vertical and horizontal asymptotes with dashed lines. And we did that. I'm going to put their equations on here. Horizontal lines have a y equals a number, and vertical have x equals a number, -2. And there we go. We did it. Number 6. So I'm going to try to keep these videos to around like maybe 15 minutes, and then because they won't upload if they take too long. It's just a big pain in the butt. All right, division and dividing fractions is multiplying the reciprocal. So x squared minus 2x minus 15, we're going to factor that. That would be x minus 5, x plus 3, -2 and -15. And the denominator, that would be x minus 7, x plus 3, times x plus 2 goes to the top, x minus 5 to the bottom. And x minus 5's cancel, the x plus 3's cancel. Final answer, x plus 2 over x minus 7. And multiply, we don't have to flip anything, it's multiply. So we're factoring the numerator. That would be a -4 and a plus 2. And on the denominator, that would be a -7 and a plus 2 times x minus 8 over x minus 4. X minus 4's, x plus 2's. Final answer, x minus 8 over x minus 7. All right, subtraction. For adding and subtracting, we need a common denominator. And in this problem, we already have a common denominator. So that's our denominator in the answer. And then we do the operation to the numerators. 8 minus 17. And 8 minus 17 is -9 over x minus 5 is our answer. Subtraction. I am going to first factor all of my denominators that can be factored. X squared minus 9 is difference of squares. That factors into x plus 3, x minus 3, minus 4 over x minus 3. So our denominators both have an x minus 3. They need to be the same thing. This one has an x plus 3. So that is what I'm going to multiply into the top and the bottom. We're just multiplying by 1. Something over itself is 1. So we're not changing the value. We're just writing it in a different form. So our denominator now, x plus 3x minus 3. And now we're going to do the operation to the numerator. 5x plus 9 minus 4 times x plus 3. And then I would simplify the top and combine like terms. 5x plus 9 minus 4x minus 12, distributing a -4, same denominator. 5x minus 4x is x, 9 minus 12 is a minus 3. X plus 3, x minus 3. And of course, x minus 3's cancel. And there's a 1 left on top over x plus 3. So I got a different answer when I did it on this problem. For some reason I multiplied by, I did a totally messed up. So the solutions that I'm posting on Canvas, obviously I screwed up really bad. I wonder if I can fix it on this thing. Yes, I can. Maybe. That was number 8. So I'm going to scribble that out, and then that will remind me to go back and fix that. Or maybe I'll just upload this to be the solutions. Anyway, simplify each of the following. X minus 2's cancel. So x plus 2 over 1, or just x plus 2. And here, x plus 4's, x plus 3's, x minus 3 over 1, or just x minus 3. Here, we have to skip, flip, and multiply. So I'm going to put the x minus 1 on top, the x plus 1 on the bottom. And now it is a multiply. X plus 1's, x minus 1's equals x plus 3 over 1, or just x plus 3. And this one is adding. So we have a common denominator. So we have x plus 4 plus x minus 4. 4 minus 4 is 0. X plus x is 2x over x plus 5. And so I'm looking at the written one. How do I undo that? That I had you guys take pictures of because I didn't post it yet. And I just didn't even do D. It was like in class. And so I was distracted, I bet. All right, this time we are solving. I'm just going to check the time. Oh my goodness, it's been 20 minutes. All right, I'm going to stop it here. I'll do this one. So we're solving. And this one is a fraction equals a fraction. That's called a proportion. You can cross multiply. So we can, x plus 3 times x plus 2 is equal to x minus 4 times x minus 3. And I'm going to FOIL that out. X squared, outside is plus 2x, inside is plus 3x, giving us plus 5x. 3 times 2 is 6, equals x squared, outside and inside give us a minus 7x. Negative 4 times negative 3 is positive 12. We're going to minus x squared both sides. That's gone. 5x plus 6 equals negative 7x plus 12. So let's add 7x. And so our x's will be on the left. I'm going to minus 6. So our regular numbers are on the right. 5x plus 7x is 12x. Equals 12 minus 6 is 6. Divide both sides by 12. So x is 6/12, which of course is 1/2. All right, you guys, that's it for video 1. And that's that.